Hello, so let us look at few more problems for obtaining the Maclaurin series. So here you are given the function log 1 plus e raised to x. So we are asked to find the expansion of uh, log 1 plus e raised to x up to the terms containing x power 4. So we have y equal to log 1 plus e raised to x. Again, നമ്മളൊക്കെ ആദ്യം ലോഗ് മാറ്റിയിട്ട് ചെയ്യാം. കാരണം ലോഗ് വെച്ച് നമ്മൾ ചെയ്യുമ്പോൾ വീണ്ടും അത് ഒരു റേഷ്യോ ആണ് നമുക്ക് വരിക. ലോഗ് വെച്ച് ഡെറിവേറ്റീവ് എടുക്കുമ്പോൾ you will get 1 by 1 plus e raised to x into e raised to x. So again you have to use a quotient rule that becomes complicated. Differentiating becomes complicated. So let us write the given function as e raised to y. So take exponential on both sides. So we'll get e raised to y equal to 1 plus e raised to x. Now from here y at 0 will be equal to so e raised to 0 is 1. So we are going to get log 2. Y at 0 is log 2. Now we have e raised to y equal to 1 plus e raised to x. So differentiate with respect to x. So that will give e raised to y. You will get y1. Okay, representing first derivative as y1. That will be equal to e raised to x. So y1 at 0 will be put x equal to 0 on both sides. Above y at 0 will be log 2. E raised to log 2 വരുമ്പോൾ 2 വരും. 2y1 at 0 will be equal to e raised to 0 is 1. So y1 at 0 will be equal to 1 by 2. So we have got this equation e raised to y, y1 equal to 0. So again differentiating, so we'll get e raised to y, y2. So use the product rule plus e raised to y, y1 square varum, that will be equal to e raised to x. Now again when x is 0, e raised to y nu parayunna e raised to y at 0 is log 2. So again 2 varum, 2y2 plus okay, so this will be y2 at 0. So 2y2 at 0 plus 2 y1 at 0 എന്ന് പറയുന്നത് 1 by 2 ആണ്. അപ്പോൾ 1 by 2 whole square വരും. That will be equal to e raised to 0 is 1. So 2 y2 at 0 will be equal to, this is again 1 by 2. അപ്പോൾ 1 by 2 വരും. So y2 at 0 is going to be equal to 1 by 4. So y2 at 0 will be 1 by 4. Now again differentiating, so we'll get e raised to y, y3 plus e raised to y, y1 y2 plus ഇനി ഇവിടെ e raised to y 2y1 y2 വരും. Then e raised to y, y1 cube varum, that will be equal to e raised to x. So at x equal to 0, so we are going to get 2y3 of 0 plus e raised to okay, other 2 varum, 2 into 1 by 2 into 1 by 4. So 2 into 1 by 2 into 1 by 4 plus next term is again 2 into 2 into 1 by 2 into 1 by 4 and plus 2 into 1 by 2 whole cube. So that is equal to 1. So therefore 2 by 3 at 0 will be equal to 1 minus, so this is 1 by 4 minus 1 by 2 minus 1 by 4. So that is going to be equal to 0. So therefore y3 at 0 is equal to 0 and നമ്മുടെ ഇക്വേഷൻ എന്ന് പറയുന്നത് so e raised to y3 plus 3 e raised to y1 y2 വരും 3 e raised to y1 y2 plus e raised to y1 cube equal to e raised to x. So when you differentiate, you will get e raised to y4 plus e raised to y1 y3 plus 3. Now we have product of three functions. So e raised to y1 ആദ്യം y2ന്റെ ഓരോ ടേമിലും ഓരോന്നിൻ്റെ വെച്ച് ഡെറിവേറ്റീവ് വരും. അപ്പം y2ന്റെ ഡെറിവേറ്റീവ് y3, then e raised to y. Let me take the derivative of y1, that is y2, അപ്പോൾ y2 square വരും. Then let me take the derivative e raised to y. So that is e raised to y1. Okay, അപ്പോൾ y1 square y2 വരും. Plus e raised to y ന്റെ ഡെറിവേറ്റീവ് e raised to y1 raised to 4 വരും. Plus e raised to y3 y1 square into y2, so that is equal to e raised to x. So we are going to get 2 y4 at 0 plus ഇനി y3 നമുക്ക് 0 ആണ്, അപ്പോൾ ഈ രണ്ട് ടേം 0 ആകും. Then 3 into 2 y2 is 1/4. Okay, so 2 into 1/16 plus 2 into y1 is 1/2, അപ്പോൾ 1/4 into 1/4 വരും. Again plus 2 into 1/16 plus 2 into 3 into 1/4 into 1/4, that is equal to 1. So we'll get 2/4 of 0 plus, so we'll get 3/8 plus 3/8 again, that will be 3/4. Write it as 3/4. Then 1/8 plus 3/8, അപ്പോൾ 4/8 വരും. So that will be 1/2 equal to 1. So y4 at 0 will be 1 minus 3/4 minus 1/2 by 1/2. So that will be 1/2 into minus 1/4. So therefore y4 at 0 is equal to minus 1/8. Not up to y4. So therefore the Maclaurin series is, so that is log 1 plus e raised to x, that will be equal to, so y at 0 is log 2 plus y1 of 0 is 1/2, x by 1 factorial വരും plus 1/4 x square by 2 factorial, and the third term y3 at 0 is 0, and minus 1/8 x raised to 4/4 factorial, etc. So this is the required series. Next problem is expand e raised to a sin inverse of x in powers of x by Maclaurin's theorem, and hence obtain the value of e raised to theta. So here let us first of all look at the Maclaurin series for y equal to e raised to a sin inverse of x. So here we will look at the general expression for the nth derivative. നമ്മൾ ലൈബ്നിറ്റ്സ് തിയറത്തിൽ nth derivative കണ്ടുപിടിക്കുന്നത് കണ്ടിരുന്നു. So we'll obtain a recurrence relation in that case. So here we will find the derivatives using that technique. Okay. So we have y equal to e raised to a sine inverse of x. So the first derivative is e raised to a sine inverse of x into a by root of 1 minus x square. So let me square on both sides. So that will give y1 square into 1 minus x square equal to, now this is y, so a square, y square varum. Now let us differentiate this. So that gives 2y1 y2 into 1 minus x square plus y1 square into minus 2x equal to a square. Derivative of y square is 2y y1. Now 2y1 will cancel off in each term. So 1 minus x square y2 minus x y1 equal to a square y item. Now let us calculate the derivatives also. So here we need y at 0. Y at 0 is e raised to a sine inverse of 0 is 0. Up e raised to 0 varum, e raised to 0 is 1. Now y1 at 0. So this is 1 a and 1. So value is going to be a. Now for y2, so when x is 0, you will get y2 at 0 minus the term 0 agum. That will be equal to a square into y at 0. Y at 0 is 1. So y2 at 0 is going to be equal to a square. Okay. Now let us take the differentiate it n times. So we will get the expression as so apply Leibniz theorem and differentiate it n times. So we will get yn plus 2 into 1 minus x square plus nc1 into yn plus 1 into minus 2x varum. nc2 is n into n minus 1 by 2 yn into minus 2 varum. Then minus x y1 into derivative, nth derivative എടുക്കുമ്പോൾ yn plus 1 into x plus n yn. So that will be equal to a square by n. So upon simplifying, we will get this. Okay. Now let us find the remaining derivatives. Okay. അപ്പോൾ നമുക്ക് നമ്മൾ ഓൾറെഡി കണ്ടുപിടിച്ച ഡെറിവേറ്റീവ്സ് എന്ന് പറയുന്നത്, സോ y at 0 is equal to 1, y1 at 0 is equal to a, and y2 at 0 is equal to a square. Now when n is 1, so that will give you y3. Okay, n is 1 and again x is 0. We need the derivative at x equal to 0. So when x is 0 and n is equal to 1, so we will get y3 minus 3. Okay, e term 0 agum. So this will be a square plus 1 y1, that will be equal to a. So y3 at 0 will be equal to a into a square plus 1 square. And next let us find the expression for y4. അപ്പോൾ y4 എടുക്കുമ്പോൾ again at x equal to 0, അതായത് x equal to 0 ഉം n equal to 2 എടുക്കണം. അപ്പോൾ first term y4 at 0 വരും, y4 at 0, second term is 0, minus 2 square plus a square into y2 varum. y2 is, okay, this is a square, not a2. So therefore y4 at 0 is a square into a square.